So welcome to CSS Animations. My name is Michael Mullany. I run Sencha and run products and marketing there. For what Sencha does is basically create JavaScript frameworks and tools and connected services. So we have Sencha Touch, which is a JavaScript-based framework for building cross-mobile applications. Heavily leverages CSS transitions, styling, and a lot of CSS3 and HTML5 stuff. I'll give you just a tiny look at it. But most of the time, we are also working on XJS, which is a desktop JavaScript framework that just came out in version 4. I don't know if anyone uses it. It's pretty popular. So without further ado, I will dive into tonight's topic, which is CSS Animations. So, and I'm going to be stuck behind this rather high desk all the time, but I feel like I'm in church, actually. It's weird. Okay, so tonight we're going to talk about CSS Animations and a little bit about SVG and Smile or Smil. Everyone says it's supposed to be pronounced Smile, but I think it should be pronounced Smil. So when you're looking at, actually before I go to this, when you're looking at web animation choices, you're basically looking at 6 choices, right? You're looking at animated images, animated GIF, or if you have a Firefox-only audience, animated PNGs. You're looking at JavaScript animation. You're looking at Canvas, which is available in HTML5 capable browsers. You're looking at SVG and Smil. You're looking at CSS animations, or you're looking at Flash. So on the desktop, particularly if you're addressing kind of edge browsers or you've got a limited audience, you have a ton of choices. And a lot of these are pretty good. Canvas has its strength. JavaScript animation has its strengths. Animated images, not so much. But when you look at the animation scorecard overall, you can see that when you choose these things, you basically kind of look at how ubiquitous is the browser, how compact is the format that is being delivered. So is it a low download, basically? How high performance is it? What are the range of effects that you can create with the animation technique? Is it scriptable? And is it web native? And as you can see, there's a lot of strengths and weaknesses. If you're doing animated images, obviously animated GIFs are supported everywhere, but they're not particularly compact. You can't script them. And the effects are pretty limited, right? It's just frame after frame after frame. If you're using Smil, Smil is basically not working really anywhere except Firefox 4, which has done a fantastic job on Smil and SVG support. But they're really the first ones out with good support there. It's a very compact format. It is fairly high performance. It has a decent amount of effects. It's very scriptable, and it is web native. In fact, well, that's one of the questions for the end. And I won't ask it now because you'll guess. But CSS3 Animations, pretty ubiquitous, particularly on mobile. Has been around for about 3 years since Apple first put it out in Safari. Pretty compact, great performance, particularly on mobile. The effects are decent, but has limitations. Scriptable, but not as scriptable as other things. I'll talk about that as part of the presentation. Obviously, web native. JavaScript and CSS, can get pretty wordy. The performance is good, but can be kind of jerky and jittery. And I'll go into that, the reason for that in a minute. The effects are pretty good. It is obviously scriptable because it is JavaScript. Web native. Canvas, a little bit limited browser availability. Not particularly compact. It is a pretty low-level API, so you get to write a lot of code to do effects. Performance, fantastic on IE9 and fantastic on Chrome. Reasonable on Safari. Reasonable on Firefox, and basically not workable on mobile. Fantastic effects. It's a low-level, bit-oriented format. Highly scriptable. That's how you do it. Web native. Flash, pretty ubiquitous, except for the major exception, which is iOS and mobile, really, actually, in general. Very compact, right? They've done a lot of work to shrink the format down as much as possible. Reasonably performant, except for mobile. That's one of the reasons why it's been kept off mobile so long. Fantastic effects, very scriptable, not web native. when you go to mobile web animation, you actually end up with a lot fewer options, right? You can do animated GIFs, great, but they're probably the worst form of animation you can do. JavaScript has timing issues, and it's pretty jittery, and I'll go into JavaScript timers in just a second. SVG and SMIL, not available at all on Android 2X, so it's just available on Honeycomb. It's actually not bad on Honeycomb, but also kind of limited support in general for the types of effects that are manipulable with declarative animations. Canvas, pretty low performance. Actually, the RIM playbook has fantastic Canvas performance, and the iPad 2 is not bad. Flash, obviously not on any iOS devices, and it's pretty low performance on others. So I don't know if we tried our CSS versus Flash ads on the Zoom, and we just couldn't believe that the Flash results were pretty bad. So hasn't been tuned for Honeycomb yet. So basically the result is that that you're facing CSS basically only. So let's talk about JavaScript timers on mobile, because this is probably the first thing that people go to when they want to do animation on mobile. So on desktop, and these are the results from John Resig's timer tests that he put out a couple of years ago. At the time, the reliability of JavaScript timers in terms of if you set a set interval or set timer, what's the actual real time that you get, was pretty awful. But then I think partly as a result of those tests, actually, the desktop browsers became a lot better to the point where IE9 JavaScript animation now is like butter smooth. It's incredibly smooth. But the same thing hasn't happened on mobile. And as a result, that when you use JavaScript animation using set timeout or set interval on some of these phones, you get really, really inconsistent results. And as a result, you get pretty jittery animations. So the iPad 2, 10 milliseconds plus or minus 1 millisecond. That's actually fantastic, and it's as good as desktop. iPhone 4, not as good, 10 milliseconds, but a big band of plus or minus 5 milliseconds. The playbook, the set timeout interval our set interval time is 30 milliseconds, plus or minus 3 milliseconds. So if you're trying to set an animation using that, you can get lower frame rates, and then occasionally you'll get spikes where your animation just jumps to where it should be because it hasn't been updated smoothly. BlackBerry Torch, very, very inconsistent. It doesn't have a GPU, it doesn't have a floating point unit, and a fairly low-powered CPU. So you're looking at 15 milliseconds, basically plus or minus 15 milliseconds. The range of performance you get around the mean is pretty huge. The zoom is worse. It is 10 milliseconds plus or minus 10 milliseconds, so you've got a huge timing range around the middle. And Android 2, it does slightly better than Honeycomb, but it's also 10 milliseconds plus or minus 5 milliseconds. So, and you can also get very bad occasional outlier spikes. So the iPad 2, for example, has I think 24 levels or 24 timers. It must do it triggers some sort of garbage collection event because you actually get a massive spike, like hundreds of milliseconds in response of the set interval. So you can sort of reliably anticipate a little bit of jitter in your JavaScript at that point. Now, there is a proposal from Mozilla called Request Animation Frame, which is intended to solve some of these synchronization problems between different types of animation. It also can reduce the amount of work that your CPU has to do if you're just trying to peg the CPU as fast as possible with set interval-based animation. So that basically means that really, for mobile web animation today, you need to look at CSS Animations fairly seriously as the main go-to for web. So what do CSS Animations look like? Well, I've prepared a little bit of a demo. So we first got interested at Sencha in web animations about this time last year when we said, you know, you can probably take a lot of advertising and just, if I have Wi-Fi, you know, whatever you're doing in Flash, you can pretty much sort of duplicate in CSS Animations, because the kind of sprite-based animation that most people do is pretty CSS animation friendly. So in the first one, who thinks the left hand is a Flash animation? And who thinks the right one is a Flash animation? Okay. Come on, guys. Okay, I'll play it again. Okay, who thinks the left is CSS? Who thinks the right is CSS? Okay. Yes, the left is CSS. Next one down, we'll give you another replay. And I'll give you okay, top is CSS, bottom is CSS. And then, you know, CSS3. So, hey, not bad. Good for CSS. Yeah, other examples of so this is a Bruce Lee quote. It really should be set to audio, but if you've ever worked with HTML5 audio, you'll know that it's really hard to synchronize it with anything else. So be like water, Bruce Lee. And this is using web fonts to get that nice chunk font. Lots of little 3D effects and swings. So, you know, pretty rich, gratuitously fancy effects. You can also do. You can't do an animation demo without a page flip. That's just the rule. So here's the ubiquitous page flip. And then one more ad, because it seems like everyone's working on ads these days. And this is actually, we cracked a Flash ad and you know, pulled it in. And you get a nice steam effect. That steam effect is actually a CSS3 hack that I'll go into. And it's all made possible by the folks at the Television Workshop and CSS3. Okay. Getting timeout. Okay, so that's just a sample of like what you can do with CSS animations. So how do you build them? Well, that is what we go and talk about next. So how do you build animations? It's really built on two building blocks. One is transitions, so the ability to basically tween between properties, so to go from one position to another, or one color from another, or one font size to another, etc. It has discrete state changes, so you can jump from one to another. You can also easily move from one to another as well, with easing curves. And transforms, which is the four horsemen of transforms, which are the ability to move or translate, the ability to scale, to rotate, and to skew. That's out in both 2D and 3D form, and I'll talk a little bit about browser support in a minute. You can also specify the transform origin with respect to which all these transforms are performed. So this is a super simple transition example. It's just an absolutely positioned div. The opacity is 1. Top is 10 pixels. WebKit transition property opacity top. We're going to move the opacity at 2 seconds. We're going to move the top position at 4 seconds. When I hover on it, I'm going to change to opacity 0 and top 45. It's going to give you something like that. and we can look at the live code. I've got a JS fiddle here. Same thing basically. When I hover on it, it goes down, and when I unhover on it, it goes back up. So that's a super simple transition example. Any questions about just the basics here? No. Okay.
So can we have multiple transition properties? Is there like a definite number?
You can transition as much as you want.
And so the duration will match the number of parameters will match the transition property, right?
Yep, basically. So it comes back up. So this is the range of stuff that you can transition according to the spec. I actually haven't tested all of them, and I know some of them are not transitionable in some browsers. Things like the stop position, for example, is not transitionable. But ideally, you should be able to transition almost anything that you can style. There's very few things that actually are not transitionable in the browsers. So for things that are continuous properties, it basically tweens. So it will tween on a color circle between your start color and your end color. For things that are discrete, like z-index, it doesn't sort of blend forward quickly. It just literally, after 2 seconds, it moves to the front if you do a hover. So this is two divs, the front div and the back div. The top is z-index 1, the back is z-index 0. But when you hover, I'm going to move to z-index 2. Where the transition property is a z-index, and the duration is 2 seconds. And you can look at sort of the live code here. 2 seconds until you hover, I'm back, and it flips to the front. So you can do just quick z-index flipping that way. So next, the first advanced topic, which is transition easing curves. Now, in all the browsers that are out there right now, there are easing curves. So basically, you can specify how fast the transition happens, and you can do it with a couple of built-in effects, or you can actually specify your own custom easing curve. So the default, if you don't specify an easing curve, is basically it starts slow and it ends slow. So you get this nice kind of smooth transition from one to another. Linear basically does an even transition. So the state is tweened evenly across the time period. You can do ease in or ease in, ease out, which is actually equivalent to the default, or ease. You can do ease in, which gives you a slow start, and then kind of a more even end. Ease out, which gives you a fast start and a slow end. New, hot off the specs presses, in W3C, CSS3 editor draft status, so you heard it here first, is step start, step end, which is very exciting because the ability to actually have discontinuous changes in a property is really handy. Before this, you had to specify keyframes that were like right beside each other and hope that people would notice that it actually was, you had a tiny bit of tweening in the middle of stuff. But now you can step. So you can have the transition happen at the beginning of a time period, the end of the time period, or you can actually specify a number of steps that it takes in between. So a really cool effect. And live code. I have more space on my home monitor. But basically, this is a bunch of transition properties left, linear ease in, ease out. So when I hover over it, this gives you a linear progression. This gives you a ease, so slow start, slow end. This gives you slow start and a fast end, fast start, slow end, and a fast start, slow middle, and a fast end. Now, the last one is a custom easing function, which I'll go to in just a second. So that is the range of using functions. So the last one is custom transition. So how does that happen? That happens, oh, right. I did everything in, yeah. So these are custom easing curves. And you specify a custom easing curve with this syntax. So you basically give it 4 coordinates, the xy of this dot, and then the xy of that dot. And as you play with things, it will actually give you a different amount of timing. So that's great. How do I have a great mental model of a cubic Bezier curve, so I don't need any help. But thanks, everyone. So now you really need a visualizer. So let me reload this. Okay, it's still downloading. I'm going to go to my go-to browser for SVG, just in case it is Chrome. Okay, somehow this changed over the weekend. So let me go to Animator. So I wasn't going to go to this early, but I'm going to go to the timing function here. Yeah. And go to the easing function. So basically, this is what you play with. This is our animator tool, which I wasn't going to demo yet, but I really want to show you the curves. So basically, you can specify the easing, with these 2 coordinates. This is P2x, P2y. This is P1x, P2y. So you can see here that this is slow start, super fast middle, slow end, and you can move these 2 dots anywhere you want. If you basically let them line up, it's basically linear. And then you can do like really crazy timing functions like this. So, the built-in ones are pretty good. Going to custom easing functions, you kind of need a good reason to do that. Those are basically transitions and easing curves. Are there any questions about kind of easing curves? Okay, awesome. So 2D and 3D transforms, you basically have 4 verbs to work with. Translate, skew, rotate, and scale. And out of these 4 verbs, you can actually get a pretty big amount of mileage. So this is the syntax for translate in Y. WebKit transition property all, WebKit transition duration 3 seconds. You specify a WebKit transform, which is you move stuff down by 100 pixels, and it will move down by 100 pixels. And I have a fiddle for that as well, but I think it's pretty self-explanatory. Now, what's really important to understand about transforms, and there's actually a bunch of things to understand about transforms, but transforms transform the entire coordinate grid. So that when you, and nested transforms, which you'll use a lot if you're actually doing anything that is a real sort of animation scene rather than minor effects, they accumulate. So if you, scale something by 150% and then want to move it by 10 pixels, it's not going to move by 10 pixels anymore. It's going to move by 15 pixels. And this means that it's actually really difficult to keep track of where the heck everything is when you're doing a CSS animation, particularly if you've got a lot of different, if you're doing custom transform origins. But if you're wondering why your stuff is not where it's supposed to be anymore, it's probably because you haven't taken into account the fact that these scalings accumulate. The other thing is that translates don't change the top and left property of an object. So if you query a top or a left, you'll be surprised after you move stuff using translate. You will be shocked to find that it is it tells you, it lies to you. It tells you that it's still in the old position and it hasn't moved at all. So you can't trust your left and top queries when you're using transforms. Second topic on transforms, transform origins. By default, if you scale something by 150%, it will scale it around the middle. If you don't specify a transform origin, it will take the middle of the div it's in. If you do specify a transform origin, you can specify it in either pixels or you can specify it in percentages of the computed size of the current div. So if you give it 100 by 100, it will actually use the bottom right corner of the block to scale things. If you give it 0, 100%, it will use the bottom left. If you give it 100, 0, it will use the top right. And if you use 0, 0, it will use the top left. 50% is the implied default. Now what you can also do is go outside the box and start to give it transform origins that are outside the block content. And that way you can start doing sort of crazy things like having it just through a rotation. It'll still just be a rotation, but it will actually move through arcs. Any questions about transform origins? Nope. Okay. So why do you use scale and translate versus dimension or size transitions? And why do you use translate versus position transitions? There's really a couple of reasons. The first is that you can try and transition font sizes, but they typically will, because they're discrete properties, they will actually jump from one font size to another. So you'll get 9 point, 10 point, 11 point, 12 point, 13 point, 14 point, 15 point. And that kind of looks weird because it does, it kind of re-renders the font while it's doing the tweening. It's kind of odd. The other thing is that things like border radiuses, shadows, strokes will auto-scale when you scale in using a transform rather than scale using positions. If you scale using kind of sizes and you've got a 2-pixel border, the border will stay 2 pixels. Everything else will blow up. If you use a scale, the border will actually stay in proportionally the same as the block content. Why do you translate versus position transitions? Well, you get high frames per second, and you also get really good sub-pixel tweening from GPU accelerations. I talked about how it doesn't affect the original page locations for the elements. That's why you do it. So 3D transforms, which today are available on desktop Safari, iOS, and the RIM Playbook. The RIM Playbook has an awesome browser, by the way. It's really cool. Basically allows you to arrange your 2D block content in 3D space. And there's a couple things that it requires. It requires a special WebKit transform style called Preserve 3D. Without this, the z-axis differences are flattened and they're projected into the XY plane, and I'll show you the effect of that in the next slide. And you've got a couple of optional things that you can do. So you can apply WebKit perspective, which adjusts foreshortening, so it automatically puts you into a scaling space. You don't have to manually scale things as they move away and towards the viewer. And you can adjust that to have kind of extreme sort of comic book foreshortening, so you can have the old fist coming out of the comic that looks like this big. And perspective origin will actually adjust the viewpoints to which the perspective is trending. So you can draw those nice. Who was the guy who invented Western perspective? Someone's got to know this. Okay. His lines. Okay. So some of the examples of what you can do in 3D space. I mean, the most familiar one is the Apple type gallery. This is just content that's been arranged in the z-axis. As you can see, it has pretty good perspective because the ones that are behind are much smaller than the ones in front. And it's just basically rotating. It's a rotating div with the content flipped up in the y-axis. Let's see, I think I've got another example. Shape deform. Yeah, that's it. Pretty well, because if there's no transforms and it doesn't understand it, you just have to make sure that you position it correctly for people without that. So you can have just have literally a film strip, and then use transforms to put it into a circle. I mean, you have to be a little bit smart about it, but it's not hard. So these are the effects of a 3D rotate. Let's say we want a poster wall. You know, the nice poster walls that kind of go back in the middle and then approach you at the sides. If you don't use Preserve 3D and you're rotating the left-hand side, so basically we're trying to create this effect. I love 3D examples because it's so hard to demo. So that's basically what you're trying to do. But without Preserve 3D, you're basically just projecting this onto this plane, and you're projecting this onto this plane. So you're not getting the benefit of the hard work you're doing to do a 3D rotate. So this is what you get when you do Preserve 3D and you put in a perspective of 1,000 pixels. So it starts to actually look properly 3D. It's bowing out at both sides. This is with perspective 300 pixels. And at 300 pixels, you're starting to get kind of a really silly effect. It doesn't really look real anymore. Typically, anything under about 500 pixels starts to look a bit comic book-like. So anywhere from 500 to 800 or 1,000 is pretty good. By the time you get to about 2,000 pixels, it starts to look really flat, actually. And then this is with moving the perspective origin. So you've moved the origin down, so you're now looking up at the poster wall, and a little bit to the left. So you can see more of this than that. Perspective origins are, you can animate those, so you can actually, as the mouse moves around, you can have the poster wall sort of look different, so it's kind of cool. So those are 2 and 3D transforms. Any questions on transforms? I couldn't agree more. These are just tools. You can use a hammer to kill someone or to hammer in a nail. Yeah. CSS animations don't kill people. Designers do.
Well, it could kill a website.
Yeah, it's just... I look upon this as when Flash first started getting ubiquitous, and there was all these crazy Flash splash screens that really just distracted people when you just wanted to get to the content. And certainly I haven't seen any of those in the last 5 years, so they kind of went extinct pretty quickly. I have started to see some gratuitous CSS animations out there for sites that really don't need it. We do a little bit of transitions and transforms on our website, really just to bring attention to certain things like a little wiggle and a little pop. But you got to make it pretty subtle, and it's got to be brand appropriate as well. So the question is, can you achieve Section 508 and accessibility, basically, requirements using CSS animations? Yes, because this is all readable. This is just a style sheet. So the text is still there in regular HTML. And if you're using screen readers or using visibility software, accessibility software, you can add your own style sheet. And the screen reader certainly can just read off the content. So that is actually the great part about CSS animations, which they're just styles. And the content is still there. So CSS animations build on top of transforms and transitions. And it basically, the goal of an animation is to affect properties during the execution of the animation. There are 6 elements that you can use in an animation. The first is how long does the animation go on for? And you can chop up the animation into multiple stages using percentages. What's the easing or the steps that I'm going to use for each section of the animation? Is there a delay? It can be either positive, meaning delay 5 seconds before you start this animation, or it can be negative, meaning behave as if this animation had started 3 seconds ago. Jump in at 3 seconds and go forward. Pause run. It's a property you can set. It's pretty buggy. I wouldn't use it. There's fill mode, which is needs a little bit of explanation. You can set the fill mode for forwards, backwards, or both. Forwards basically persists the end keyframe at the end of the animation. Otherwise, compliant browsers are supposed to move the object back into its original underlying property set. Backwards basically says if you've got a delay at the very start of the animation, I want you to jump to the first keyframe, even though the play state is supposed to delay for a couple of seconds. Then you can also have normal or alternate iterations. Normal basically says repeat the animations X times. Alternate says repeat the animations, but do it in reverse every other time. So CSS Animations. Oh, here we go. I explained it. So this is how you write a CSS animation. You go at WebKit keyframes, and soon, hopefully, at dash Mos and at dash O and at dash MS. You name your animation move, so you can actually reuse the same animation pattern across multiple style sheet or multiple objects. And this basically does a 4-stage transform from 0, 0 to 30, 0 to 30, 30 to 0, 0. And you refer to or you activate the animation by going WebKit animation name move in the particular style or class for that object. So in this case, it'll move it over, it'll move it down, move it back, the iteration count 1, timing function linear. Now you can sort of play with this a little bit. And do other things. So you can specify, if you want it to steps. Step. Okay, I got the syntax wrong. Would you get the idea? So that's the basics of animations.
Can you shoot the film back if you don't like it?
Yeah, sure. Minus 5 seconds. Delay. Sorry, 5 seconds. This is Chrome. I think it works. There. See? Jump to the first. So that's what the delay does. Yep.
I've worked a little bit with these keyframes. They did an animation on desktop, works smoothly, did that same animation on mobile, and at the very end of the animation, it did a big jerk.
Yep.
Is there a standard solution for this, or is the fill mode, which I hadn't known about before?
Yeah, fill mode was probably it. Fill mode forward. Back. Okay, so ideally you want this to be scriptable from JavaScript. Here's where CSS Animations aren't that great. It basically gives you 3 events that you can listen to: animation start, animation end, and animation iteration. It also gives you a incredibly unhelpful function called window get computed style, which returns the current transformation matrix. So I know you've all been waiting to practice your linear algebra. I know I've been. So thank you, browser manufacturers and spec makers, for making us relive Math 21B. So this is what you get when you query get computed style. On something that has a 2D transform. It basically, you get a matrix that represents the current product, matrix product, of all the applied transforms. So if you've done separate rotates or skews, etc., they will not give you back, rotate, 20 degrees. They'll give you this very helpful matrix back. So you basically need to do some linear algebra. And if anyone wants like a little JavaScript library that they can write, something to extract meaningful data from get computed style will be a nice thing. This is how you do a counterclockwise rotate. It'll give you the cosine in radians, the negative sign in radians, etc. That's how you kind of work back from what the rotation was. This is a scale by. Basically, it takes the various skews, rotates, scales, etc., and munges them into fewer values. So it's actually hard to extract what the current scale is, for example. Now you can try and interpret it by just figuring out, well, if I'm 2 seconds after I triggered the animation, I should be here. But if you're not there, this is the way that you figure it out. So animations are awesome, but they do have limitations. They're essentially sprite-based, right? You have a block. You can do stuff to that block. You can move it. You can scale it. You can rotate it. You can move it behind other stuff. You can skew it. But that's it. They're pretty verbose, but the good news is that they're going to compress down nicely when you serve your content on your gzip-enabled web server. Everyone does have their web server gzip enabled, right? Right? Steve Suiters, high-performance websites. I shall gzip my content, right? There's no guaranteed synchronization with audio or other mechanisms, so you can trigger stuff off at the same time and just hope your timers work out. But you can't resync stuff. Get computed style, obviously not a friendly format. And then you can, personally, having done a bunch of these animations personally, where's the transform origin? Like, stuff is not working properly. Where is it? Why is it rotating in that weird way? Because after you nest a couple of these things and they're moving around and scaling, you just completely lose track of the start. So you can't use it to animate or deform shapes themselves beyond a simple skew. You can't do progressive drawing, and you've got no motion blur, which I know all you Flash artists and developers will say, you can't do an animation without motion blur, man. So, but you can't without SVG, which does have directional blurs, and you can actually see it live in Firefox 4, which is awesome. So let's talk about some cool animation hacks that you can do because you're playing with the rest of CSS3 typically when you're doing animations. Highlights and lens flares. So because you've got gradients and you've now got an alpha channel in gradients, you can do that nice effect, in CSS. You can also do shape blurs, transparent fills, text shadow blur in a transform. You can also do movement on a curve. And I will attempt to show you a couple of those things in action. So this is an animator. You're seeing a really late alpha, so if it crashes, it's not my fault. So here we've got basically 3 divs nested in each other, a top-level container, and then a next-level container. We're going to attempt to show you the crazy stuff you can do by hacking timing curves into motion curves. So I'm going to move this top-level container here in this keyframe over here, and I'm going to move this container down here. So when we play it back, it's going to look like that. Now, the cool thing is that I can play with the easing curves of each of these things and make the motion pretty crazy. So that's for that one. And that's for this one. Let's see. And you can start doing sort of motion on a path by varying the timing curves that both of your keyframes are working with, which is kind of neat. So that's a way of hacking motion on a path, even though you only have linear transforms to work with in CSS by nesting basically two differentially timed divs. Hacking awesome shapes. So you don't have blurs to work with in CSS3, but you do have shadows that you can blur. So what you can do here is something pretty fun, which is you can set the color of the type to transparent. You can put a stroke in, say a 2-pixel stroke. Sorry, I'm not going to put a stroke in. You can put a shadow, and you can make the shadow anything you want. Let's make it, yellow. Okay. And then you can blur the shadow. Let's do a 20-pixel blur or a 15-pixel blur. Right. And then you can do a skew or rotate. On the blur, so you can do a 45-degree blur. And you can actually sort of play around with these crazy blurs so that if you want to do things like a steam effect, like we did in our thing. That steam, I want to show it to you again because it's kind of neat. I closed it. That steam was basically a 2 and a 5 shadow blurred and skewed and kind of differentially rotated, so you didn't actually even know that it was a 2 or a 5. The cool thing is that if you combine this with web fonts and non-traditional fonts, you can basically get sort of any blur shape that you want, which is crazy. So crazy CSS hacks. Where can you use animations today? CSS Animations. You can use it basically, red is IE. That's a shock to everyone, I know. Chrome 10 doesn't have 3D transforms. It sort of does, but not really. SMIL is kind of an amber alert stage in Chrome 10. Safari 5 doesn't have inline SVG or WebGL. Firefox 4 is pretty good, but it doesn't have animations or I think reflections or 3D transforms are still missing. iOS 4.3 doesn't have SMIL or inline SVG, but Playbook, Honeycomb have all the rest, at least nominally. Chrome versus Safari, they both support -WebKit, but they have a couple of limitations. If a frame is missing a value that you're animating, Chrome will try and interpolate. Safari will actually go back to the intrinsic property, which is sort of the correct way to do it, although the spec is not entirely clear, so that's one of the things that they rewrote. If you have 2 transforms on an object, Chrome will try and transition. Safari will only apply the last transform, which is correct, because that's the way CSS works. Chrome will drop anti-aliasing and has no GPU acceleration for the most part. Safari and Mobile Safari do a pretty good job of retaining anti-aliasing and have GPU acceleration. I think it's because particularly Mobile Safari just basically snapshots the screen and moves the image around under the covers. The Playbook has kind of Safari quality animations as well. So that's it for CSS Animations. Are there sort of questions about CSS Animations before I do a really, really quick SVG and SMIL thing? Okay. So SVG and SMIL, who knows SVG? Okay. SVG, XML format, drives you crazy because you keep on forgetting to close your tags. It does maintain fidelity with zoom. It's a vector graphic format. It's really rich. You can do complex paths, shapes, strokes, all that stuff. SMIL is also a rich, complex language. It has great layout capabilities. You can embed multiple media. You can actually synchronize everything together. It's widely used, but in very unusual places, like SMIL is actually the format for doing MMS for rich texts. It's in the Netflix playback viewer, and a couple other places, I believe. I've heard that. But it has pretty spotty support. The thing that it does have that you want is that it has shape animation. You can do a lot of other stuff in CSS Animations, but the one thing you can't do is alter the shape. So the rule here is that from and to shapes have to have the same number and order of path types: lines, arcs, quadratic and cubic, Bezier curves. Basically, you can transform that into that using SMIL and SVG. And this is what a shape deformation looks like. You basically do the obligatory namespacing. You have to ID your group. You create a path with a fill and a stroke. And then the drawing is actually the D equals, move to 200, 200, and then draw a line from 28, 100 to 100, 200 to 200, et cetera, et cetera. The Z at the end just basically closes the curve. And then you do the animation by basically giving the same set, but with different values separated by semicolons. So what this looks like, shape animation, is, this is what it looks like when it's working correctly, which is something moving around from one to another. It's actually pretty smooth across all the browsers. The issue here, of course, is that the fill isn't animating correctly. In general, there's a lot of, even though something like a modernizer will say, yep, SMIL's there, use it, Chrome actually has pretty spotty support. So when you go to Firefox, which has really good SMIL and SVG support, you get this, which is how the fill is supposed to properly animate. But it's a key missing part of CSS Animations, and it's where SVG can do really good stuff. Other stuff that you can do in SVG is just purely through declarative formats, is stuff like this. So if you want to view the source of this, it's pretty actually easily understandable. In SMIL, you can reuse stuff pretty easily by just referring to an X-link. And you can pick up SMIL, the relevant parts of SMIL and SVG, I think in about a day and a half from scratch. And it's probably worth doing, although it's actually far easier to do something like Raphael. So this is someone else. So this is what you get when you do kind of an insane amount of SVG animation. This is not Flash. It's just using path deformation. This is a guy called Daniel Rodriguez, lives in Venezuela. And it's super cute. Am I going? Am I going? Okay, go back. Yeah, okay, come on. Get the browser. Get the mouse. Get the mouse. Get the mouse. So, fun with SVG. Now, the easier way by far than learning raw SMIL and SVG is to use something like Raphael or use XDraw from XJS. Basically animates, instead of using SMIL properties to animate stuff, you just use JavaScript to change SVG properties directly. And Raphael actually is an abstraction layer on top of SVG and VML, so you can use it on top of Internet Explorer as well. And a couple of the things that are neat there. Nope. Yep. This is X4 charting. This is using SVG because we're on Chrome, and you get really smooth animations, radar charts, and this we use VML on IE6 and IE7 and IE8, so this actually works cross-browser, but that's kind of neat. And then Raphael demos are pretty awesome. So we sponsor the development of Raphael as well. You can download, so you can do kind of neat stuff with Raphael. What are the other kind of cool stuff? Yep. So you can move stuff around. Very smooth, very high frame rate. And the good part is that most of the stuff will work on mobile as well. So you can get smooth animations on mobile, cross-browser, except for Android 2. Okay. So CS Animations, so the summary is that CS Animations are here. SVG shape animation is near-term usable. You really do need to test it everywhere if you're going to use SMIL. Easier to do things in SVG like motion on a path versus CSS. You really have to do a lot of cross-browser testing. SMIL translations are incorrect in Chrome. Negative text offsets are ignored in Safari. Filters only work on the playbook in Firefox 4. There's a lot of things you need to test with if you're going to dip your toes in SMIL. Probably better off to use your favorite framework. Tools can help. I would not advise anyone to hand craft SVG paths. You should just throw them in Inkscape and then extract them. And that's basically the state of CSS Animations and SVG, plus SMIL.